Okay, we'll get going with our next panel here, and I'm sure we're going to have some folks that are coming back in after lunch, but I wanted to introduce David Mandernack, who has been our project director for the transportation subcomponent of our activities with the consortium, and has been doing quite a lot of work also with the Space and Energy Innovation Center, but he's assembled quite a number of great folks to talk with us about how transportation is an area of real growth and opportunity here in Central Florida and throughout the state going forward, and look forward to a great panel. Thanks, David.
Well, we do have a pretty full panel. It's one of the largest, if not the largest panel, but we're very fortunate having the members that we have here who willingly came from all different parts of the country to show up here. Space is a transportation system. We are lucky in having a very robust space center that's just not too far from here, and has demonstrated over the many years that it can do many great and noble things, and as a transportation system. But the interesting insight that we have had over the years is some of the things that are on spacecraft that make spacecraft be able to go into space and do those things are at a subsystem level are becoming more and more common with terrestrial transportation. And so what we have arrayed today are some of the representatives of industry that are pursuing those things in a high-tech fashion. Britta Gross is from General Motors, and there's a couple Chevy Volts out there. If you open up the hood on it, I don't recognize a thing in it anymore. It's a high-tech car, both on the inside and the outside, and some of the materials that are used. We have also Joe Lunny from Proterra, and I hope you all got to see the bus early today, but we were able to use the bus yesterday, and we drove all over Kennedy Space Center for the second time. We drove the EPA was here with us, and we toured portions of KSC, and I actually got to see a demonstration of an aerodynamic truck that's also out front here from the SmartTruck company. They'll talk about some of the features that their company has done, combining aerospace technology with transportation technology. And then we have John Erwin from Saddle Creek Logistics, and they're going to talk about not only some of the innovative forward thinking that they have, but they have gone through the pain and difficulties of converting an entire operating business from diesel fuel commodity over to natural gas, and they've got a very good story about how to do that. So welcome all, and we'll begin with Britta Gross.
Thank you. All right, thanks a lot. All right, so the goal today is to very briefly, so we have enough time for questions, just get enough teasers out there so you can think about what vehicles look like today, get you thinking about where there might be some good matches between skill sets, and especially here in Florida, and where transportation's headed. So what I'd like to do is I always like to focus really on the Volt, because that's just a stunning piece of technology. It was very complicated to do the Volt program. I think I said these exact words last year. But it's a battery vehicle that when the battery's depleted, it seamlessly rolls over to a gasoline generator that'll take your vehicle cross country. So it's really two cars in one. All battery vehicle, all speeds, accelerations, terrains, and so on, all battery. If there's any charge in that battery, it's going to run electric. And so 40 miles was this target on the program, because it was based on Department of Transportation data that said most Americans, 80% of Americans, don't drive more than 40 miles a day. You think you do, but you really don't. So if we could do that sort of 80-20 rule, knock off 80% of everyone's miles and get off of that oil, we would be doing a very big service to satisfying and beginning to solve our energy security problems here, and also the emission problems on our vehicles. So so the Volt became this almost this iconic symbol right now of very complicated technology and what's possible. So the one thing I do like to always set the stage on, though, is that batteries are part of a solution going forward, but batteries are probably never going to do everything for all kinds of transportation modes. Heavy vehicles, as you get heavier vehicles, as you do a lot of longer distance driving, to be honest, a pure battery electric vehicle is probably always going to be sort of limited in that area. It's great for known distances, when you know the range of your vehicle and you know where you travel every day, it's great. But you're not going to be able to spontaneously drive 400 miles or take a cross-country trip in a battery electric vehicle. But most people don't need to do that. All right, so there's a big market for pure battery electric vehicles. The Volt is something in the middle, an extended range electric vehicle, so it's electric with that range extender, the gas generator. And so that can satisfy an awful lot of sort of these longer duty cycles. And then also as the vehicles get a little bit heavier, it's got the capability to also move a little bit more weight. But then when you're really talking about highway driving and heavier vehicles, you're really talking about something like hydrogen fuel cells, another electric solution. And you guys at NASA in this area are very, very familiar with hydrogen fuel cells. And it's why automakers will not stop developing hydrogen fuel cells, because it's the only known technology solution for vehicles that'll go long distance, no emissions from the vehicle, which is very key to the automotive industry right now, is getting out of the emissions problems with the exhaust from the vehicles. And then third, it refuels in 3 minutes, just like gasoline. It's the only thing that'll do that. So hydrogen is going to have to play a role. The fuel cells are really efficient. They're already 2.5 times as efficient as a gasoline engine. So burning anything in a combustion engine is not nearly as good as using a fuel cell and running hydrogen, for example, through a PEM membrane. All right. So then briefly, I've already explained sort of what the Volt is. 40 miles electric, and then 350 miles gas, like any traditional vehicle. You can take this vehicle cross-country from Orlando to Los Angeles, starting right now. There are 2 more products we have coming out to the market. The Spark is a pure BEV vehicle, a lot easier to do a pure battery vehicle. The technology is just not nearly as complicated and complex. We're going to roll that vehicle out only in California and Oregon right now, a few other global markets, but that one will be restricted here in the United States until we see how the market really is for a pure battery electric vehicle. And then we got the Cadillac ELR coming out sometime in the next 12 months. And that Cadillac ELR has got basically the same guts as the Volt does. So it's an extended range electric vehicle, but that luxury brand. So again, we're trying to diversify without too much distraction on the kind of products out there. We do have a lot of faith in extended range electric vehicles and what that means to the marketplace. We think that's the only technology that'll really go mass market, and that's really important. All right, I did want to just briefly show you what the market looks like. So there are a couple plug-in hybrids, and plug-in hybrids do a lot of blending. So you probably can't do you can't do a lot of acceleration and still stay on the battery. You probably can't do accelerating onto the expressway, and it has pretty short range at even lower speeds. So maybe the plug-in Prius is, don't quote me on this, maybe 11 miles, and maybe the Ford C-Max, I think 22 miles, something like that. The extended range electric vehicles with the Volt and the Cadillac coming out in the next year, these are full performance electric vehicles, and then they have the range extender on it. And then you look over here, look what's in the market for the battery electric vehicles, getting very, very crowded. With the Spark we have coming out this summer in California, Oregon, the Leaf everyone knows, Tesla RAV, Honda, and the Ford Focus. So very, very crowded over here. It's going to be interesting to see how the market plays out here in some of these fields. The market's doing very, very well. I want it to do better, but it's doing actually very well. We've already sold, as an industry, 100,000 plug-in vehicles, and we just passed that milestone in the last couple weeks. 100,000 vehicles is a lot. If you remember back to the EV1 days, there was a lot of commotion and news about the EV1, but do you realize we only sold like at least 1,000 of them? 1,000. So our industry's now done 100,000 of these. So it's a very different time, a very different market, and a very different technology. Anyway, and last year we tripled the sales of the Volt over the year before. So things are really looking up, but we do need to do more. I just wanted you to have a sense of where are the plug-in vehicle sales in this country. It isn't just a California market. If you look at this map, and you can look at the penetration colors up there, the orange means you've got 5 to 20 in a certain, this is a zip code map. Blue is 0 to 5, gray is really blue. It's just hard to see when you've condensed it this much. There are some green zones on the map. There's one in Florida, I'm going to show you in a second. And there are some reds out here, like in the LA area and Sacramento, in the San Francisco Bay Area too. So it is a national rollout. These vehicles are being purchased everywhere. Here's the map of Florida if you want to take a look at it. You can see the one green zip code down here. I think that's Boca Raton. I'm not quite sure if that's what that is. But you can see they're spread out all over. And so that's good. I think that's good news for the market. They're out and about. the thing that's really good about the plug-in vehicles is they're winning and sweeping all the awards. They're winning awards because electrified transportation's really nice. It's a luxury feel, it's quiet, it's smooth. The launch from an intersection is really, really exciting. These cars are really a blast to drive. And the more people understand that, the more this market's going to grow. The two awards that I'm really happiest about, because it sort of shows you the foundation of the market and how important this is, we got the technology and the safety right because we've got the 5-star award from NHTSA and we've got a top safety pick by the Insurance Institute. This is really important to give consumers a real sense that this is a safe technology, well vetted and so on. And the other one up here is this recommended best buy from Consumer Reports. And also the Volt 2 years in a row has won an award for customer satisfaction. So 92%, 93% of Volt customers would definitely buy this car again. Unprecedented, those kinds of awards. That's better than any car in the market. So these are two signs, I would say, that say this is really important. So if batteries don't go far enough, I said before, then maybe hydrogen fuel cells is the answer. All automakers are working on it. Announcements are starting to come out. You can see them about production plans. A little bit harder because the hydrogen infrastructure challenge, but it can be done. And so a little bit different. Picture, I showed this last year when I was here too, about hydrogen fueling stations. It can be done. In fact, you can do it really nicely with some of the imaging and symbolism of some of the stations, like the one in Munich, which is a really nice Lindy station. And then I just wanted to leave you with one thought starter, and this has got a lot of ideas in it. So this is our V2V program. This is our NV, it's called. Electric Networked Vehicles, I think is what it's called. Oh yeah, Electric Networked Vehicles. The notion is that we could begin to address with really broader issues than just emissions and energy security. We really need to start talking about parking congestion and in addition emissions in very congested areas. I mean, look at the Shanghai or the Beijing challenges, okay? And we could look at our own cities as well. One way to sort of merge our world and public transportation world is to think about a notion where as we develop the technology, these are two-seat vehicles, okay? Two-seater vehicles, you could drive wherever you want. But these can also convoy with vehicle-to-vehicle communications. This is now something that's a big effort right now in the automotive world, is to work on how do you sense where the vehicle ahead of you is, behind you, and next to you for complete safety. If these are networked together, they actually convoy, imagine like a bus. But when you get where you want to get off on the off-ramp, you just take your bus seat and you go off where you want to go, as opposed to having to jump on another form of transportation or get off and change buses. You're in your car, but you platooned down the expressway as far as you wanted to go with the platoon. So this is a melding of worlds. You can imagine how complicated this is from an information security standpoint, from a communication standpoint, from a programming and software. I just wanted to sort of tease you with, we have big problems to solve in the automotive world, and that's maybe one of the bigger opportunities right now. Thank you very much.
Very good. As I mentioned, we're fortunate to have the Proterra team here. Joe Lunny is with us. He's been with us several times now in the Space Center, bringing their bus through and allowing the many from the community to actually get a chance to ride in it. It's as you mentioned, it's a different experience to have something that'll move you around with making no noise whatsoever and nothing coming out the tailpipe. So, Joe.
Thank you, David. Yes. Thank you. It's nice to be back. I appreciate the opportunity to bring our Proterra bus today, and hopefully you had a chance to look at it on the way in, or at least visit with us. Hope that you had that chance, because we're loading it now for its next appointment. Unfortunately, it stays very busy. And what I normally would do at this point would be to open with a 25-slide PowerPoint presentation I'm going to spare you with. And that would go through all of the features and benefits and the savings, such as fuel, maintenance, and other things of the Proterra bus. It's very unique. I'd be happy to talk with anyone afterwards regarding these features. But today, instead, I would like to open with a video that would give an overview of Proterra, and then a second video short that Tallahassee produced for the APTA convention this year. I think you'll get a real kick out of Tallahassee's presentation, so if you don't mind.
The life of a transit authority manager is not easy. Maintenance costs are escalating. Emission standards are tightening. Fuel costs are rising and rising and rising. Every day, your job gets tougher and more unpredictable. Until now. Introducing the Proterra Eco-Ride electric bus. It's built to future-proof your fleet. There's no noise because there's no engine. There's no pollution because there's no tailpipe emissions. There's less maintenance because there are fewer moving parts. The Eco-Ride is more fuel efficient than any bus on the road, has a lower carbon footprint than any bus on the road, and offers the best total cost of ownership in the industry. The Eco-Ride is currently in operation at Foothill Transit in Pomona, California, with new buses and charges in construction for Via San Antonio and Star Metro in Tallahassee. It fully charges in under 10 minutes. It automatically connects to the fast fill charging station without any driver help. It offers more than 20 miles per gallon, 300 miles per day, and 30 miles per charge. Its lightweight composite body lasts up to 16 years. It carries 64 passengers comfortably. It's made in America, and it's backed by Silicon Valley's leading venture firm, Kleiner, Perkins, Caulfield & Myers, as well as General Motors Ventures and Mitsui & Company. Imagine never having to worry about diesel costs, or tighter emission standards, or escalating maintenance costs. The Proterra Eco-Ride electric bus makes it all possible by making your operations more predictable. Future-proof your fleet with Proterra.
Now this is the video done by Tallahassee. Go ahead.
I love the way this bus handles. It has plenty power for an electric bus. You know, it's the first time I've ever driven an electric vehicle. I haven't even driven a golf cart before, but this thing has power. And I tell you what, it's a smooth driving car. If you ever driven a luxury car, you can compare this maybe to a Cadillac or something like that. Man, this is smooth. I love it. I like the idea of, you know, when you drive and you release the brake, it automatically recharges the battery. So I like that aspect of it. I like the idea of being a part of this technology, you know, where I can go and pick the patrons up, you know, and something new, you know. It says 0 emissions, and that's exactly what it is. There's, you know, I love this bus.
Hello, I'm John Gregory, and I'm a coach operator at Star Metro. And welcome to Star Metro's new electric bus. It's very smooth. The drivers will enjoy all the electronics and the ease of operating of this coach. The passengers will enjoy the ride. It's very quiet. The engine is only about this big. It's so different. The electric bus is just really just electrifying.
Good morning. My name is Mike Johnson. I'm one of the mechanics here at the Star Metro Maintenance Facility, and we are really excited about our new electric buses, and we look forward to working on these and keeping them in service. I'm pretty sure it'll be an electrifying experience.
I'm thankful to be a part of the Star Metro team and involved in this new technology. I think it's the way of the future, and I'm excited to be a part of it.
Yeah. Well, I hope you enjoyed that. For me, I've joined Proterra, let's see, it's been about 8 months. It's been a real exciting ride after being into the transit industry for about 25 years. Proterra has just exploded. I'd like to say that in June of 2011, Proterra had 30 employees. They're now in South Carolina, Greenville, with 220,000 square foot facility. And I think at last count, we're somewhere in the 190 employee range, with, I think, 2 pages worth of openings still online. So please join us online. I'd love to speak to anybody about the features of the bus. In a nutshell, you know, I get asked a lot of questions, and one of them is, of course, you know, what the savings are on the bus. And typically on a 30,000 mile annual route, you're looking at savings of potentially about $500,000 over the 12-year life of the bus. And Tallahassee has claimed that their savings, they project about $135,000 worth of savings in maintenance. And of course, there's always the zero emission part of it. So it's a wonderful product. I'm happy to be here. It's a great company to work for, and I'd love to speak to anyone after the presentation.
As Joe will attest, I've been talking to him for a couple of years now, trying to steal any part of their factory that they have up there and allow us to perhaps in some fashion support the supply chain. But in order to do that, we have to work out through some of the arrangements we have here in the area where they might actually have their buses being used in the area. And there's a few areas. There's a big city called Orlando, which is maybe possible. But other than that, the technology that you saw, and I'm glad that you had the opening of the hood. If you look at that, it looks a little bit like the Hubble telescope when you open up the back end of that. So I think we have the expertise at Kennedy Space Center that could be assistive in helping pursue and advance some of the technology. It's a good match. Next is Johnny Bohmer from Performance Racing, and he's going to talk about some of the work that he's already been doing out at the Space Center for a couple of years or more, where they do aerodynamic testing of vehicles. They look like race cars. In fact, they are and have been. But there's an interesting aerodynamic thing that you have to do. You test designs on the computer. You know, if it starts as a napkin design and then eventually gets into CAD/CAM and then gets into other systems that show the flow of air and so on around a vehicle. But ultimately, you have to take it out to a place and test it in the real world. And Johnny's going to talk about how they do that and some of the applications that he's had. Johnny Bohmer.
Back again, thank you. Let's see. Okay, what's this thing? Okay. Well, as David mentioned, we do a lot of testing at the Kennedy Space Center, and we were lucky enough to get a Space Act agreement with the Kennedy Space Center. And we originally started working on the Space Act agreement. They had a lot of criteria that required you to be somehow doing something that's beneficial to the environment. And we were working with some aerodynamic coatings and with the Pratt Whitney project on the metals and things. So we had enough qualifications to get in and to come out there and do testing. Now the Space Shuttle runway, if you're familiar with it, is one of the best pieces of concrete in the world. It's 3.5 miles long. It's 300 feet wide. It's as flat as it can be. It has a slight crown in the center, but it's a very nice place to test. Very private. And so we started initially going out there testing some aerodynamic coatings to lower coefficient of drag, which we're still working on, as well as the Panboy metal project. And it's worked out really well, and we've had a lot of findings that have been pretty instrumental in some increases in some of the performance areas we're working on. And that's a picture of the Space Shuttle runway there. We were founded in 2008 as a performance automotive company, and at that time we were currently going for a world record to have the first car to go 250 miles an hour in the standing mile. And it was a lofty goal when we decided we were going to do that. We were told by a lot of engineers that the terminal velocity on that particular chassis was going to be like 228 miles an hour. And this was coming directly from Ford, and some of their engineers that had done modeling programs and wind tunnel testing to the tune of about $10 million. So at the time, in March of 2010, we went 252 miles an hour in the standing mile in about 23 seconds. And the engineers were there from Ford, and it was at a pretty well-known race, and they asked how we did it. We said, well, we didn't have a wind tunnel to tell us we couldn't. So, so what we found is we have a saying that the only substitute for the real world is the real world. You can do a lot of engineering, a lot of modeling, you can do all the different things, and what it boils down to, and what we found at the Kennedy Space Center, is that you have to go out eventually and do the testing and actually get the aerodynamic data. We host some of the, I just mentioned that there. We host some of the NASCAR teams and some of the other race car teams at the Kennedy Space Center. And we've come to the conclusion after meeting with a lot of the top engineers and really in the world, these are some of the top guys. Some of the NASCAR teams are that go out there. They're very private. They like it because it's private. When they come out there, they're not thronged by people wanting autographs and stuff. But when they get out there, they find a real world data that no matter what they do, and they spend millions of dollars in wind tunnels, they can't achieve those results and get the findings, by doing it in a wind tunnel. They have to go to this area like this. And it's straight, it's long, and it works real well. We've had the Audi team come all the way from Germany. They would spend an incredible amount of money with anywhere from 50 to 80 employees. And we brought them to Brevard County. Last year they brought 82 people. And this is the entire Audi Le Mans team that also was racing in Sebring. I don't know if there's any race fans in here, but last year Audi won 1, 2, 3 in the diesel hybrid, which was diesel rear engine, electric motors in the front. And they swept the race. The first 2 cars, 1 and 2, were diesel hybrids, and the third car was a straight diesel. But they attributed that win to the sweep they had by going to the Kennedy Space Center and getting live data. And the engineers that are doing this, we got 52 guys on laptops, engineers studying 1 car live feed. I mean, I'd venture to say the technology in their car is amongst the highest of anything on the planet. And it's a $27 million car, and they're coming all the way from Germany. So this is a great opportunity for people to come out. We've been very fortunate to have our Space Act agreement. We hope to continue to move forward with that. And some of the teams that come out don't want to go through the rigmarole of getting all the Space Act agreement or then hurry. So we host them. We let them come into our Space Act agreement. We facilitate them to come out. So it's worked out real well for everybody. And the gentleman from SmartTruck, they came over. They were in a hurry to get out there because it was short notice, and we allowed them to come in. And I believe they found some good data there. Who will be speaking here? Mike will be speaking in a few minutes. So it's a great place. You can test tractor trailers. There's a lot of things you can do out there, and this is one area where NASA can increase their visibility and bring in some funds. The Audi team that came last year and this year, they spent a few $1 million in Brevard between here and Sebring, and they stayed for 10 days. We hired catering companies. They spent 50 people eating 3 meals a day. So when these teams come in, not only does it help NASA with the fees that they get for the runway rental and things, it also helps the local economy. And we go out there quite a bit. We're coming back in July with another race car team, and they'll again they fly in here with their jets and all that stuff, and they spend the money. So it's a great testing ground. This is just another photograph of some of the runway things that we do. This is just some of the stuff I mentioned earlier. It's 3.1 miles long. It's flat. It's very straight. Desirable weather year-round, I'm going to argue with that one. But it rained on us yesterday. We were there yesterday. Luckily, the testing they were going to do finished. So an hour after they left, it looked like the skies opened up. What's really interesting is we do run into a lot of very high-level engineers when we're out here, and they're interested in what we're doing, and they offer suggestions and some help. The private secluded part of it's very nice. And it is the only facility of its kind that allows for long-duration, high-speed coast-down testing. And what that is, coast-down testing is, a lot of people think you go out there with a race car just to go fast, and that's not really what you do. When we recently went 283 miles an hour in the Ford GT that's out front, it's a new world record. It's the fastest standing mile in the world. It's a Guinness Book World Record holder. But we didn't go out there just to do that. We did it to prove that panalloy parts, which I mentioned in my earlier presentation, would work and not shatter or break and facilitate the vehicle doing what it did. But what people do in coast-down testing is, like the NASCAR team typically will go to 185 miles an hour, and they coast. And all they do is they let that car go down to almost zero. And they do this 3 or 4 times. Because it's so long, they can go up to 185 and coast down 2, sometimes 3 times on the full length of the runway. Then they turn around and do it going back. Then they drive back into the pits, they put the car on the scales, and they measure everything that happened, and they make aerodynamic adjustments. Well, why is this important? It's a race car. All the stuff that happens in racing trickles down to exactly what you're talking about earlier. Everything that we do, if you take away everything that NASA's done and the race car companies have done, there wouldn't be much around here right now. So technology trickles down from the high end down to the low end, cars and things, regular passenger cars. And the coast down testing is very important. There's not many places you can do it. And yesterday when you were testing your tractor trailer, I was amazed how far that thing coasted. A lot of inertia behind that. So that's a very important part of the Kennedy Space Center that we've been able to utilize, and we didn't realize how important it was until we got out there. This is pretty much what I just said about the coast down testing. That picture right there on the left is the car that won Le Mans in 2010. That's a diesel hybrid electric, which uses electric motors in the front and diesel in the rear. That's Kevin Harvick's NASCAR from Richard Childress Racing. If you look in the background, you can see the mate-demate device where they take the shuttle on and off the plane when it comes from California. And that's the car that won Le Mans last year with one of the drivers. I think that's Marco Bonanami, I believe, an Italian guy. But the cars are incredible. The sophistication in them is very high level. And this is a company, Audi, that owns the Volkswagen test track. And I've always asked them, why don't you test there? Because they own the Volkswagen test track, which is miles long. It costs them over $500,000 a day to shut that track down because Volkswagen has hundreds of cars doing 24-hour tests in all kinds of different things. I'm sure like the GM Proving Grounds they have. And so it's more advantageous for them to fly all the way over here with all their crews, fly their planes over, and spend all the money in the hotels. They all stay in Cocoa Beach, but they get to do this coast down testing uninterfered. They don't have to stop. They can set up. Okay, more about the coast down testing and the aerodynamics, and that's a picture of our car when it's, I believe, when it set the world record recently. And let's see. This is some of the stuff that we found, and it's kind of a secondary project, but it started off as one of our additional projects. We developed a coating. We spent about 3 years developing it to lower the coefficient of drag, and we went to a wind tunnel testing big and then had some testing done, and we noticed about a 2% reduction in drag at about 100 miles an hour. Well, that's pretty fast, and at 50 it's 1%. That's not a big deal, but if you do it globally and you look at the large numbers, it adds up. We noticed at 250 miles an hour, we gained about 6 or 7 miles an hour. So, and when you're at that speed, the types of things that we're doing, it's very difficult to achieve a higher horsepower. It takes a lot of horsepower to go 1 mile an hour. It's just, so when you gain 5 or 6 miles an hour, just by having a coating on a car, it was very important. And the coating is, and they're a sponsor for our car, and we've done a lot of testing, and it's worked out really well for us, and the stuff works good. Keeps the car fairly clean as well. On a second note, yeah. There we go. Increase of performance and increase in efficiency. Again, you've heard the old saying, win on Sunday, sell on Monday. That's Audi's take on things. It used to be NASCAR's, and they still try to achieve that as well. But racing is a huge thing, and you will always get a lot of notoriety from high-performance vehicles, like the Space Shuttle. It's a pretty high-performance vehicle. So, that's a photograph that they were nice enough to allow us to take at the VAB with the team that won Le Mans, and that's the car that won in 2010, our car, and then of course one of the, I think it's the mock-up shuttle, and then the VAB. No, too far. But that's pretty much it, and it ties in directly to what we're doing with Panalloy, the aluminum alloy. We work with Pratt Whitney, and we're very happy to have the space agreement with NASA. And it's a great way to generate economy boosters in this area, and from what we've seen, it generates a little bit of jobs as well. So, any questions? Yes, sir.
I'm wondering, out of curiosity, how does the coding work, and can it be applied to industrial paint jobs for the car?
Yes, it can. It's really, we spent about a year and a half developing. It's quite expensive. We finally were able to solve a puzzle of how to get something that's not a real high in one chemical or another. It works on anything. We're talking with airline manufacturers right now and some fleet stuff, and we're working with Pratt Whitney right now on they have a program with tractor trailers, and they're wanting to do some testing. There's a lot of variables in coating vehicles if you don't keep it clean, if the airplanes aren't clean, that can wipe out what you're trying to prove. So we just know it works well, it keeps the vehicle clean, and it looks nice. And it has a very similar effect like Rain-X. So when we put it on the entire car, windshield, everything. You don't put it on the tires. It's too slippery. It's very slick. When we coat the vehicles, you can throw a rag on the hood and it kind of slides off. So, and it lasts about 6 months, but and it's actually a little difficult to get off the vehicle. We recommend it goes on not over wax, but just like straight on the paint, and it works real well. Around town, I don't know how much fuel economy you're going to see in stop and go traffic with all the variables that are out there. In most of the aerodynamic situations, we found 40 or 50 miles an hour is where you start to see some improvements. We've noticed in the wind tunnel testing that we did, which was done at a reputable wind tunnel testing facility, that it started to work at 18 miles an hour. But it was a very small amount, up to around 40 or 50, then it got in the 1% range and it climbed. And I guess exponentially, we were limited in the wind tunnel, but probably around 200 to 300 miles, 250 to 300 miles an hour, it's going to continue to work. And we've had it on some airplanes they've claimed, which we don't have scientific data to prove it because I don't have enough access to the airplane, the pilot, and get the true input. But we've had some airplanes that have claimed they've increased their fuel economy by 3 or 4%. So that's good. But the private jets seem to clean their planes a lot more often. The commercial jets clean them every 30 days. So. But that's pretty much it on that. If anybody has any other questions. All right, thank you very much. Did it again. Good job with it.
Very good, thank you. Next is John Erwin from the Saddle Creek Logistics team, and they've got their truck out perhaps still, or did it have to go? Okay, very good. Go ahead and let him do his presentation. There you go.
Good. Good afternoon. I'm John Erwin, Director of Transportation for Saddle Creek Logistics. Saddle Creek Transportation at headquarters in Lakeland, Florida. And I saw Dave a few months ago in Houston at a conference I was speaking at, and he asked me to come speak here, so I'm excited to do that today. A little bit about Saddle Creek. We are a logistics company. The transportation is a part of it, about a third of the company, but we have warehouses all across the country. You can see our locations, and anywhere you see the stars and some of the other locations, we have transportation, but our headquarters are in Lakeland. We've got a big sustainability program at Saddle Creek, and we do everything from speed control, idle control. We monitor the trucks with satellites. We've got special tire programs. If you saw the trailer outside, it has an auto air system that fills the tires on the trailers. We've got aerodynamic mud flaps that allow the air to go through. We've got trailer skirts, wheel covers to keep the air from going in, and most thing we've done recently is natural gas. And that was obviously a big step up in our sustainability program. Why did we do it? One of the main reasons was to reduce our dependence on foreign oil. With 400 trucks in our fleet running 100,000 miles a year, we burn a lot of diesel, and that was a huge expense for us. So we're trying to find a way to reduce our expense and get us off foreign oil. It's also to improve our reliability and our protection from potential disruptions. Here in Florida with hurricanes, obviously when there's no power, you can't run. We have the gas that comes underground. We have a backup generator, so if the power's off, we still have gas. We can run our trucks. To meet our goals for environmental sustainability, if you got a chance to hear the truck, it's 10 times quieter than a diesel at idle, so it's very quiet. It has a lot of reduced emissions. I'll talk a little bit about that in a minute, and it's safer. If you see a normal fuel island where you have fuel all over the ground, anything that's spilled just dissipates, so it doesn't spill or drop. And future cost savings as potential diesel prices rise. You know, something happens overseas in the Middle East and prices can go up 20 cents in a short period of time. So natural gas is very stable as far as the pricing. Just a couple things about the environmental impact. We're comparing one of our diesel tractors that may burn about 17,000 gallons of diesel a year, switching our 102 tractors, which is what we did. We reduced our carbon footprint by 11.4 million pounds annually. And I have a hard time understanding what 11.4 million pounds of carbon is. I can't understand what that is. So we tried to put it in other terms, so it's equal to 6,000 Volkswagens, equivalent of 150 million plastic bottles, equivalent of planting 219,000 trees every year. That's numbers that I can more understand. This is a map of all the public fuel stations in Florida 2 years ago when we started. Okay? So when we decided to do this, we had no place to fuel. So you talk about the chicken and the egg in a lot of presentations. So we had to build our own fueling station. So we had to decide where we could put it on our property, where it fit, how we could make it work. We decided to go with, we have two different types of fill. We have a fast fill and a time fill. If you see a lot of the refuse trucks driving around that they run all day and they sit at night and fill, that's the time fill application. Our trucks, when they get back, they fill up because somebody else is going out in it shortly. So we have a combination of both. Well, the trucks pull up and they can fill up for 4 or 5 hours if they're not going right back out, or if they're slip seated, we've got a fast fill station. This is Ed Hadley, who's the driver who brought the truck today. He's one of our trainers. Our drivers fill themselves with compressed natural gas versus liquefied natural gas. Our drivers fill up themselves. They don't require any kind of face shields or any type of protection. So they picked it up just like going to the 7-Eleven and filling up their car. This is a picture of our Generation 1 tractor, the day we got it. And I'll show you just a couple pictures of what it looks like in a minute. Our Generation 1 tractor, we ordered 40 to start with. We built a station, had 40 trucks ordered, and at the same day, we got our first truck and pumped our first gallon. So it doesn't do any good to have 40 trucks sitting in the lot if we can't fuel them, so that worked out. We have 130 diesel gallon equivalents on that tractor, and we can go about 500 miles with that tractor. They began arriving in December 2011. We pumped our first gallon the same day, and received our 40th tractor at the end of the first quarter. And last year we ran about 3.5 million miles on natural gas. We're one of the largest fleets in the country doing this here in Central Florida. Aerodynamics, we talked about that, and that's something that's really important, especially in a tractor that gets 5.5, 6 miles per gallon. It's very important. We do everything we can to improve the aerodynamics. You can see the aerodynamic mud flaps. You see the wheel covers to keep the air from going inside. You also have little LED indicators that if the fuel or if the tire pressure gets below 2%, they flash so the driver can see and know they need to air their tires up. This is a Generation 2 tractor. It's a little bit different, a little bit more technology. The technology improved a little bit. It's the same tractor, but the tank on this side is carbon fiber. It's lighter. The cabinet in the rear is all aluminum now, where the first one was steel. So that's improvement. We have 62 of those tractors. There's a picture from the side. You can see on the other side of the tractor there's no tank, and there's 4 here. So this truck has 140 diesel gallon equivalents. I can go 600 miles with this tractor. We ordered 3 Generation 2 tractors to test. We went with 10 gallons more for the 140 gallons. We have 62 total. In our fleet today, we have 102 trucks running on natural gas. You'll know them when you see them running up and down the road. You'll see them now. They have the cabinet. It's not a sleeper. It's not a sleeper for small people. It's extra tanks for the gas. Natural gas takes up more room because of the volume. So you require extra tanks. So the Generation 1, we have 40 of those in service, the 130 gallons. Generation 2, we have 140 gallons. We should receive our Generation 3 tractors. We have 2 on order next week. And that will be the 12-liter engine, which is new coming out, which will be able to do a lot more for us. And we plan to start with 100 next year. We also have a compressed natural gas yard tractor. We have a lot of trucks and trailers moving around in our yard. We have a lot of yard tractors, so we invested in a natural gas yard tractor while we have the fuel. We also have a pickup truck that we converted. Our very first driver the first day, if you think about that map of where the fuel stations are, it's kind of like one of the astronauts. When he left that day to go to Miami, was he going to have enough fuel to get back? So if there's an accident on the interstate or they get stuck somewhere and for whatever reason they didn't fill up enough, they don't make it quite back, we came up with rescue vehicle where we drive out, offload a little bit of fuel, and make it back. I'm just going to go through these real briefly. These are things that people said why this wouldn't work for us. There's 12 things, we call them the dirty dozen, but if we had stopped at any of these, we wouldn't have done this. And there's a little bit of truth in every one of these. The tractor's too heavy. Because of the gas and the extra tanks, they are a little heavier, but we've worked really hard to lighten the trucks up. Not enough range in the miles. When we first started doing this, you could only go about 300 miles with the tank configuration. Now we can go 600 miles. That's all a driver can do in a day anyway. The 9-liter engine is too small. They can't pull 80,000 pounds. We do it every day. The miles per gallon is terrible. There's no savings. The miles per gallon is about 10% less than you get with the diesel because it's less efficient, but at half the cost of the fuel, it makes up for it. The ROI will fail without government assistance. Well, the new bill that passed, we didn't have 2 years ago, so we're making it work. Maintenance costs are too high. The fuel does burn a lot hotter, so there are some issues there, but it also burns a lot cleaner. Natural gas has 8 times less carbon than diesel, so it burns a lot cleaner, so the engines are a lot cleaner. The drivers won't like them. The drivers actually love them. They're automatic transmissions. They don't smell like diesel when they go home. They don't have to shift. They really like them. Shop modifications are too costly. With an LNG facility, you have to do a lot of modifications because of the liquefied natural gas. But with CNG, we don't. We don't keep them parked inside overnight. We keep the shop doors open, so that has not been an issue. When we first started, there was no way to really measure the miles per gallon of these trucks. We had to do it with spreadsheets and forms that the drivers filled out. Cummins and people that worked together and came up with telemetrics inside the tractor where we can actually measure the miles per gallon at the engine, and that's been very beneficial for us. Permitting construction are too slow, won't match with the trucks. It took us 6 months to get from beginning to end, and I mentioned the trucks arrived the same day as the fueling station was ready to go. It's not safe. That's one of the things that our drivers are concerned about. The flash point of natural gas is about 1,200 degrees versus 300 or 400 for diesel, so they're much safer. If there's a fire or anything happens, it vents at 200 degrees, and it's got to be between 5 and 15% concentration to burn, so the gas won't burn. And lastly, we kept hearing about it's only for short haul. It's only for local type deliveries. Well, with 600 miles, we can do just about anything anybody else can do with the diesel truck. And that's all the driver can do in a day anyway. That's it. Any questions?
Okay.
One question on the train. The mechanics training for maintenance.
The natural gas trucks are basically a gasoline engine. They're spark ignited. So it's more like a gasoline engine than a diesel engine. The real training is in the high pressure system. That's the biggest danger for the mechanics in the training. Otherwise, it's a spark ignited engine that requires PMs, oil changes, filters, just like a regular. Brakes, air conditioning, everything else is the same. So not a lot of extra training. There was some additional, yes. Freightliner is the tractor manufacturer, Cummins as well, and Allison, the transmission. So we've had specific training from each of those. Yes?
On your filling and vehicle storage, you had mentioned that you leave doors open, you don't leave them in the shop overnight. Did you have to engage with an FTA to review certain regulations?
Well, we work with the local fire marshal. The regulations are not very specific for that, so it's your local fire marshal has the most say of this. So we had a grand opening, we had the fire marshals there, they've been involved with it. We've had for first responders out to work with us. We've got an information sheet just so if the truck is in an accident, they know what to look for, that type of thing. But it's basically working with your local fire marshal.
Follow-up question. It's a little, not quite related, but similar. With the filling station implementation that you put in, are you networking with any other CNG vehicle users for filling access?
At this point, we were the only ones in the area. There is a Refuse Hauler Republic has a fuel station about 6 miles away. So we've partnered with them. If we have an issue or they need some fuel, we can do that. There's a couple of companies in Tampa that are getting natural gas trucks. We've talked to them about helping each other if we need to fuel at other locations. But we pretty much stand alone.
at this point.
Thank you.
Anything else?
All right, last, Mike Henderson from SmartTruck. He's the chief scientist and has one of their vehicles out front that just yesterday went flying down the runway in a pretty good place.
I'm a little bit of an odd duck in this meeting because I'm an aviation guy, and when I was at Boeing, I had a speaking coach, and among many things, he told me that the duty of the last speaker in a panel like this is to help get the program back on schedule if it's running a little late. So taking that advice, I'll just say thank you for listening to me. Now, I'll go through a few things, and I'll try to keep it short, but I think you might find this interesting. Let's see, which button? Right side? The other right, okay. So, SmartTruck is a company that has been dedicated since our start in 2009 to providing really high-end aerodynamic improvements to tractor-trailer rigs, full long-haul tractor-trailer rigs, on an add-on basis, so that it didn't have to be built in the OEs, and provide substantial improvement, everything from 5 to nearly 14% mile per gallon improvement. So again, how did an aviation guy who spent 32 years in Bohmer and worked on all these neat airplanes you see here get involved with trucks, and what kind of technology are we really bringing to this? And you know, this is an array of the predecessor company to SmartTruck, BMI, which I formed when I took early retirement from Boeing to go do some more interesting things. Everything from supersonic airplanes up there to winglets for MD-80s. We did bullets and ballistics. Got involved with NASCAR when the Car Tomorrow first came out, and we were a race team for a while, and so we did our own cars. Did a body for a hybrid vehicle. Sorry, Britta, it was a Ford. Very interesting year-long program. As we've heard, electric vehicles are challenged to cruise for range. Drag plays a big part in it, and yet they can't sell an ugly car. And so we spent a year working with designers, helping them learn how to design low drag cars that actually people would buy, that were good looking. It was a very interesting program, and it was a fuel cell hydrogen hybrid, so very similar to some of the programs you saw today. And we actually got involved in a hybrid van, had the same problem on a big draggy body, and we were able to reduce their drag by 30–40%. So this is how we kind of got started. And really, when we were doing the Ford hybrid and the van hybrid, I got introduced to a gentleman from the EPA who's sitting right down here, Mr. Mitch Greenberg, and he was interested in the Ford program and other of our stuff. And we had dinner one night, and he said, "Mike, why in the world don't you guys do a little bit of this high-end aerodynamics for big trucks?" Because, and I didn't know anything about it. The aerodynamics of a big truck at this point, but Mitch informed me that over half the fuel on a long-haul Class 8 truck goes into fighting aerodynamic drag. Now, you know, from cruising up and down I-95 out here, there are a lot of those trucks out there. And at 65 miles an hour, half of their fuel is going into aerodynamic drag. So we took a quick look at it, and lo and behold, you can make big savings with fairly modest aerodynamic changes. We'd done a lot of testing for the racing program, and so we had some tools both on the design side, basically CFD and aerodynamic tools, also on the testing side to apply to this, and basically ended up getting the program funded in 2009, designing aerodynamic parts. See if this has got a pointer. Yeah, it does. You can see a fairing here, a fairing back here. There's actually one on the top that's hard to see. That's one of our basic systems, about 6% fuel mileage savings. We go right up with other components that aren't shown here to, as I mentioned, around 14%. We went from our initial funding in 2009 to basic production and first delivery in 2010, and late 10, early 11, to the point now where we have a production in the range of 1,500 to 2,000 a month. And we have, what, Mitch, 30,000 in service, round numbers. And so the response of the truckers to this product was very surprising. And we formed a separate company, SmartTruck company, when we got funded to do this. Now, one of the reasons I'm here today is that NASA played a role in our initial development of these parts. Let's see, I'm not going back. Here we go. Being from the aerospace industry, you think, well, he was a wind tunnel guy. You go do everything with a wind tunnel. But what I learned at Boeing over 30 years was all the problems with the wind tunnel. That we spent as much time trying to figure out what the wind tunnel didn't say and how it would really fly than we did doing the testing. Give you an example. My career in aerodynamics early at Boeing was really to get Boeing out of the wind tunnel and find a better way to do it. And we worked with NASA on the CFD to do that. And that's been successful to the point that the first airplane I worked on, the 727 at 25,000 hours of wind tunnel testing, the 787 that just came out had 5. All the rest of it was done with CFD, but you still need some testing. And the aircraft industry turned to NASA and others for very complex, high pressure, sometimes cryogenic wind tunnels to have a wind tunnel that would work to confirm that the CFD was doing the right thing. Well, those things are way too expensive for someone in the truck business to use. And so we turned to the coast down testing as the technique of choice. Now, there are protocols that the SEA has, the Society of Automotive Engineering has for coast down testing for cars, but they don't work for trucks because trucks have a very low drag to weight ratio. They're heavy and they coast forever, so you can't use the prototypes for cars. So we had to develop a coast down protocol for automobiles. And there really was only one facility that could be used for that. So in 2010, we went to Kennedy for 2 weeks in 2 sessions, learned what it really was going to take to do coast down testing for big trucks, and then learn how we could use smaller tracks because not everybody has access to Kennedy. We had to have a Space Act agreement to do that. And unfortunately, it expired, and thanks to Johnny, we were able to do a test yesterday because he let us in on his Space Act agreement. But that was critical to us developing a test technique, which is more like, for me, flight test data than wind tunnel testing and more accurate, so that we could use other tracks to do this. And had we not had that capability, I'm not sure we would have been able to produce our parts and get them into service as fast. So I think the Space Center here has a terrific facility that they could apply to other companies. I know from Johnny's presentation that Audi and the other folks have discovered it. But it really is a world-class facility. And of course, being from Boeing, I've worked with NASA my entire career, and not just the Space Center, but Langley and Ames and Mountain View. So really terrific capability that hopefully other people in the industry will take advantage of. And I'll just quit there and answer any questions that folks may have. No questions?
Are you making the parts yourself, or?
We contract their manufacturer, and then we kit them and distribute them.
What about what's
The big fairings are made out of plastic, the same plastic material that floating docks are made out of. Very tough, very heavy, very impervious to the environment. So we've been very happy with the durability of those parts. And then, of course, the metal bits that hold it on. And they're scattered around. There are plastic manufacturers in Georgia. Our headquarters is Greenwood. We're neighbors of Proterra. And the metal parts are made in Greenwood. Yes, sir.
You mentioned passing around the CFD analysis. How long?
I'm sorry, I've shot too many rounds of skeet, so I'm a little deaf.
CFD analysis. You said you have because we were passing around CFD analysis.
Yeah.
How many weeks, months, or days?
We found out we had to have a very large, very detailed solution to do things, especially underneath the truck, where it's a pretty nasty environment. You've got ribs, you've got suspension components, you've got landing gear components. All that had to be modeled, and that meant that the CFD solution was enormous. If you did that on your desktop, which you could do, it would take 2 weeks to get a single one. We use big cluster computers right now. We have an arrangement for a commercial license with Oak Ridge National Laboratory. use Jaguar and Titan. And so we get overnight turnaround with those. I mean, it's not free, but it's an accommodation that really made the rapid turnaround and design refinement possible for us.
Missed your website.
Pardon?
I didn't catch your website.
It's SmartTruck.com.
Okay, thanks.
I want to make sure.
Yeah.
SmartTruckSystem.com.
Okay.
I can't keep up with this yet. I'm just a scientist.
It's very Googleable.
Thank you, appreciate it.